All right, guys, today we got piecewise functions. Piecewise. A piecewise function is defined, but with at least has two equations. Each one has a different part of the domain, which means different part of what x can be. Remember, domain is x, what you can use for x. So it's going to look like a weird graph. It's going to have different parts, different pieces. That's what's called piecewise. Let's look at a couple here. First of all, they're going to give you a piecewise function. That's what they look like right there. And these numbers over here tell you when to use which equation. The way you'd read this is you would say g of x equals this when x is less than or equal to 1. G of x equals this function when x is greater than 1. So they're going to have you just find some values. They're going to say, okay, figure out what g of 1 is. So you got to figure out where to put the 1. G of 1, because it falls in here, it's either less than or equal to 1. It is equal to 1. I'm going to use that equation. So I'm going to say 2 times 1 minus 1. Work that out, you get 1. So g of 1 is 1. The second part says find g of 5. Now 5 fits here. 5 is greater than 1, so I'm going to use the second equation. So I'm going to do 3 times 5 plus 1, which would be 16. And that's all you do. They give you restrictions on the right-hand side for when you use which function, and you just use that function to find the value. Not too bad. Okay, so next I want us to graph a piecewise, and if you notice on this one, they gave us 3 different equations to graph, so I'm going to, just go with that. So the first one says this right here, first 3 functions, I should say, says negative 3 halves x minus 1, but this one starts at negative 2. That's my x coordinate. My x value is negative 2, and it wants less than negative 2. So what I'm going to do first is I'm just going to plug in that negative 2 in here. When I do that, the 2's cancel, which gives me a positive 3 minus 1, which is 2. So I'm going to go to that point. I'm going to go to negative 2, 2 on my graph, which is right here. And I'm putting an empty circle there because it doesn't equal negative 2. It's just less than negative 2. Now, I'm going to use the slope right here to find my other point. Slope is negative 3 halves. And remember, I'm going to go less than negative 2, which is, let me click on this here, which is this direction. I'm not going to go over here at all because I want less than negative 2. Less than negative 2 is over here. So I'm going to do the slope. Slope is negative 3 halves. So I'm going to go rise 3, run negative 2 to right there. That's my second point. I can just connect those, and my line's going to do that right there. So that's the first part, the first piece of the piecewise. The second one says x plus 1 between negative 2 and 1. And also both equals. So first thing I'm going to do is I'm going to plug in negative 2 in for the x. If I do that, I get a negative 2 plus 1, which is negative 1. So my first point is negative 2, negative 1. Filled in circle because it does equal there. Then I'm going to plug the 1 in. If I plug 1 in, I get 1 plus 1 is 2. So I'm going to go to 1, 2 right there. And that's the second piece. That's the middle piece. It doesn't go forever. Notice it's just between negative 2 and 1. That line is just between negative 2 and 1. And the last one just says y equals 3. Y equals 3 is a horizontal line that goes through 3, but we're going to start it right here. We're going to start it at 1, so I'm going to go to 1, 3. It's an empty circle because it doesn't equal 3, and the graph would be, it's going greater than 1, which is to the right, so I would go to the right. So 3 different parts of that graph, right? 3 pieces to graph a piecewise. So graph each equation one at a time, using the restrictions. If you notice, I just plug numbers in every time, the numbers that they gave me to use, and figure out, oh, am I going to go to the left side of that number or the right side of that number, and kind of go that way. Okay, now we're going to go backwards. Write a piecewise function for the graph shown. So I'm going to start down here at the bottom. First of all, they're all horizontal, so that's just going to be equals 1, because, or y equals 1. So the y is already over here, so equals 1, and that graph is between 0, and it actually touches 0 and 1. It's not a filled in circle at the 1. Then it jumps up to here, so y equals 2 right there, between 1 and 2. Notice it at the 2, it jumps up again. It doesn't actually equal the 2. Then it equals 3 from 2 to 3. And it's going to looks like it's keeping on that pattern. That's actually a famous function we're going to do later called the greatest integer function, but that's not that important right now. But hopefully that's not too bad. It's kind of a weird thing, but piecewise functions are graphs that are in different pieces, or functions that have different pieces to them based on this over here, based on what the domain is, based on what your restrictions are. So we'll work on this quite a bit tomorrow. Make sure you got it. I know that's pretty short. Kind of showed you one of each, but gives you something to look back on too, maybe after the lesson also. And hopefully everything is good. And we'll work on this tomorrow for sure. See you then.